So this video shows you how to deal with the rational function in general, meaning that we are going to see how to find the vertical asymptote, the horizontal asymptote, the domain, the range, the x-intercept, the y-intercept, and then in the end we are going to find the graph for this rational function. So let's just go ahead and get to work. First up, we see that there's nothing that we can reduce. So this one, I would say, it's nothing that bad, I will just say. Anyway, go ahead and get to the first one. For the vertical asymptote, we look at the denominator and we make it equal 0. So we get 8x minus 3, and of course we put it equal 0. And solve for x, you get x is equal to 3 over 8. And then that is it. So just say x is equal to 3 over 8. Next, we have the horizontal asymptote. So that's to put the f of x as y. And then we have 2x plus 1 over 8x minus 3. And again, we care about this, care about that for the horizontal asymptote, right? The x cancel out, and then 2 over 8, which is just 1 over 4. So that's it. Y is equal to 1 over 4. Done deal. Cool. Now, for the domain, let's put it down right here. Again, this right here, we cannot reduce anything, so nothing too tricky. Just go ahead and make the bottom not equal 0. Domain, you have to state the restriction. So you're going to say 8x minus 3 cannot be equal to 0. Well, in that case, we can see that x cannot be equal to 3 over 8. And based on this, we can write our interval notation. If you look at the graph of this real quick, let's say here is 3 over 8. We have an open circle, meaning that x can be any number, but just not this, right? So x can be any number, but just not that. So look at this as the interval notation. We go from negative infinity to this. So let me write that down right here. 3 over 8. And then be sure to use a parentheses because you do not want to include 3 over 8. And then union, the other part, which is again parentheses, you go from 3 over 8 to infinity. Yeah, that's it. And then you are supposed to write everything in one line, but I cannot fit over there, so that's that. Okay, for the range, this right here, it's not bad, but I would prefer to do that all the way at the end. Now let's look at E. Right? Let's look at E. Again, usually do the range at the end because that's the trickiest one. So let's just have that habit for that. For the x-intercept, we are going to make y, which is this, equal 0 and then solve it. So we get 0 is equal to 2x plus 1 over 8x minus 3. But you see, if the fraction is equal to 0, that means the top has to be 0. So we just have to look at 2x plus 1 is equal to 0. And then solve for x right here, we get x is equal to negative 1 over 2. So that's that. And because x-intercept is a point, usually I like to write this as negative 1 over 2, comma 0. And again, this means the x value and this means the y value. This is not the interval notation. Alright, for the y-intercept, so let me put that down f. For the y-intercept, we are going to just let x equal 0 and then plug in. Remember, f of x is the y, and then we have 2 times 0 and then plus 1 over 8 times 0 and then minus 3. So we see this is just negative 1/3, right? So that's pretty much the idea why it's equal to negative 1/3 here. And again, y-intercept is a point, so we'll just write it as 0, comma, negative 1/3. Cool. Lastly, let's look at the graph for this. And to do a sketch of the graph, this is what we're going to do. First off, we have the vertical asymptote as 3 over 8. So we are going to just put down a vertical dashed line right here as 3 over 8. So let me just say this is 3 over 8, like so. And this is x equals 3 over 8. And we also have the horizontal asymptote at 1 over 4. So let's say this right here is 1 over 4. Y equals 1 over 4. Cool. Okay, and we are also going to label the x and y-intercept. Negative 1/2, comma 0. So let's say it's right here. This is negative 1/2, comma 0. And we also have 0, comma negative 1/3. So let's say 0, comma negative 1/3. Let's say this right here is negative 1/3. Cool. And technically, we should also be checking the sign of the function, meaning that when does the graph go below the x-axis, when does the graph go above the x-axis, and things like that. And after you finish all the graph by your hand, you can just use a graphing calculator to double check and things like that. Let me just tell you guys how things are. If x is less than this, right, -1/2, you get positive. It's actually like this. Just follow along. The graph will look like this. Why? Because you see that I know the curve has to touch this and that point, and then when you go all the way to the left, the curve has to become flat and it has to go really close to 1/4. And when you have the curve right here, it has to go straight down. And if you pick a number bigger than here, you will see that the curve is actually going to be positive. So let's go ahead and do that. So it's actually going to be above this right here. And again, you can just double check with your graphing calculator. Now, if you look at this, once you have the graph, you see that x cannot be 3/8. We said that right here for the domain already. And for the range, you see y can be going from -infinity to positive infinity, except for this number. The curve does not cross this number, namely 1/4. So for part D, we have to make sure that y is not equal to 1/4. So let's go ahead and go back here and then just say we have to go from -infinity to 1/4, and we will have to put down a union, and then we go from 1/4 to infinity. So that's that. Yeah, I just want to make sure that I write the interval notation on one line, so that looks much better. So this is it.